Hi friends, we have already seen what is the advantage of defining functions, what it takes to define and call them, and what is the purpose of nested function definitions and nested function calls. Now whenever we made call to a function, control was transferred to that function, statements within it got executed and control was returned back to the place from where call had materialized. That is good as far as understanding the mechanism of a function call is concerned. But realize that merely calling a function, passing control, executing statements and returning the control is not the motive behind definition of functions. We want communication to happen between functions. And how to carry out this communication is what we wish to understand today. Let's do that with the help of a program. Suppose we have a function called calsum. As its name suggests, it is supposed to calculate sum. Sum of what? Sum of its arguments. How do you mention the arguments? Well, you mention the arguments here as maybe x, y, z, and then calculate the sum saying x plus y plus z, and whatever is that value, you return that back to the calling place. And which is that calling place? This is that place from where I am calling the function calsum, and while doing so I am passing values 10, 20, 30. These in fact are the ones that get stored in xyz. So xyz contain 10, 20, 30. You calculate the sum to be 60. You return that 60. 60 that you return gets assigned to S1. Once assigned, we may promptly print it out. Not necessary that we should pass only constants. We can assign the values 1, 2, 3 to variables a, b, c, and then make a call to calsum and pass a, b, c to calsum. So you are passing arguments a, b, c, collecting them in xyz, adding them, returning the value. This time you collect it in S2. A, B, C that we are using here are known as actual arguments, whereas X, Y, Z are known as formal arguments. We may collectively print S1 as well as S2. Now a few tips. This return keyword that we are using is going to do two things for us. It is going to return the control back to the place from where you made the call, and it is also going to return the value of x plus y plus z. Whatever it turns out to be, that value will be returned and control will also be returned. Suppose we have a return without any expression. If we do not say return x plus y plus z, if I merely say return, in that case the function will return a type known as none. Means nothing is returned, but you indicate that using none. Do not think that a function will always have some or the other return statement. For example, if you remember the other day when we learned nested functions and function definitions, we had not talked about return. Still our functions work. Means we may have a def and a function name and a series of statements within which there is no return. In that case, when the call reaches fun, statements in it get executed and reaches to the end, executes the last statement and control will come back. Again, when it comes back, it will be returning a value none. That's what is mentioned here. If a function reaches the end without encountering any return statement, in that case it returns once again a null. So a return without a parameter or no return, both are the same cases. Both are going to return the control back and it will return something of the type none. Now here we are returning only sum of x plus y plus z. Tomorrow I may want to return the product of x, y, z and also the average of x, y and z. So multiple values I may be tempted to return. If I am to get that done, I will have to pack these three values either in a list or in a tuple or in a set or in a dictionary, and then manage to return that list, tuple, set or dictionary. So returning multiple values is no big deal. We just have to pack it in a suitable container and return that container. Then another important thing, if you make any changes in values of xyz in the cal_sum function, suppose you say x equal to 35, y equal to 45 and z equal to 65, and then you return the control back. When you do so, you will find that ABC do not change. Means any change in xyz is not incumbent upon values of ABC. ABC would continue to hold the original values. Whenever such a thing happens, it's known as a call by value. Any change in xyz will not affect the values of ABC. In general, I can say that changing formal arguments do not impact actual arguments. xyz are formal arguments, ABC are actual arguments. So changing formal does not change the actual. In that sense, formal arguments are like a Xerox copy. You change the copy, original remains intact, untouched. Such a call is known as a call by value. And lastly, here we are returning an integer x plus y plus z. But tomorrow I may have a cal_sum function which has multiple returns. If some condition is true, return one value, else return some other value. Now these two different values that I am returning are free to be of different types. One return may return an integer, second may return a float. Or first may return a float, second may return a list. That's what I mean when I say that a function can return different types at different times. In one call it may return an integer, in next call it may even return a list. Don't be too surprised with that. Which is not the case with other languages. That is why this point becomes important to note. Now we passed ABC, we collected them in XYZ, and we said that ABC are actual arguments and XYZ are formal arguments. Well, there is a lot of details that is to be understood regarding arguments. Let's begin that by first identifying the types of arguments. Well, first are known as positional arguments. Then you have keyword arguments. Variable length positional arguments means we do not know how many are there. Sometimes they are 3, sometimes 5, sometimes 10. We don't know how many positional arguments are there. That is the third scenario. And fourth is we have variable length keyword arguments. These positional arguments and keyword arguments together are known as required arguments, whereas variable length positional or variable length keyword arguments are together known as optional arguments. So you have required arguments and optional arguments. We want to understand each one of these. Let's begin with positional arguments. As the name suggests, positional arguments means arguments have to be passed in correct positional order. Let me give you an example of this. Suppose we have a function fun which receives ijk, then prints out the value of I plus j, and k it converts to uppercase and then prints it out. Having done this, let's now try to make a call to this function fun. Here is the first call. 10 and 3.414 that I pass get collected in I and j, and they can be easily added. 13.4 is the result that will be printed out. And the third argument that I passed is rigmarole, which is a string. It got collected in k and I converted it to uppercase and then printed it out. This is fine. However, if I decide to change the position of these arguments and make a call which says rigmarole 3.14 and 10, this is going to cause an error. The reason is simple. Rigmarole is a string. If I do a string plus float, it is meaningless. Similarly, 10 that I am passing and collecting in k, it's an integer. There is no question of converting that integer to uppercase. So position means order in which you pass the argument becomes important. That's how positional arguments work. In this case, we are having 3 actual arguments and 3 formal arguments. And rule is that their number must always match. If I am passing 3, I must collect 3. If I am passing 7, I must collect 7 arguments. So on and so forth. In short, I can say number of actual arguments and number of formal arguments must always match. Good enough? Let's now move on to the next one, that is keyword arguments. Keywords means really variable names in Python terminology as far as arguments are concerned. They can be passed out of order, unlike positional arguments. Means their position in the call does not matter. When you make the call, you pass actual arguments. The position of these actual arguments does not matter if you are using keyword arguments. Reason why order doesn't matter is the variable names are used to match the arguments. Let me give you an example to clarify this statement. Suppose we have a print it function. I, A and str is what it receives, and then prints it out using the call to the print function. Print is a built-in function, whereas print underscore it is our own user-defined function. Then I call it this way: A equal to 3.14, I equal to 10, str equal to Sicilian. Here the order was I, A, str, where here it is A, I and str. But it hardly matters because we are very clearly indicating that A's value is going to be 3.14, I's value is going to be 10 and str's value is going to be Sicilian. That is why position doesn't matter. We are indicating in which variable name what value should be collected. Similarly, I may alter the order and say str equal to Sicilian, A equal to 3.14 and I equal to 10. This call is equally okay. If I say str equal to Sicilian, I equal to 10 and A equal to 3.14, this should equally be fine. Would it be? Str equal to Sicilian, I equal to 10, A equal to 3.14. However, if I try to say S equal to Sicilian, J equal to 10 and A equal to 3.14, that's going to be a problem. Because variable names cannot mismatch if I am trying to make use of keyword based arguments for a function call. So that's going to certainly result into an error. Whereas these 3, as we said, would work perfectly okay. So basic difference between positional arguments and keyword arguments is what? That in positional arguments, you don't have to mention the name of the variable anywhere. Based on the position, it will do a one-to-one correspondence between actual and formal arguments. Means first variable's value will go into first variable of formal arguments. Second variable in actual arguments, its value will go to the second variable in formal arguments, so on and so forth. This in normal arithmetic we call as one-to-one correspondence. Whereas in keyword arguments, position is unimportant. What is important is the variable name. Once you indicate that, see, my variable A is going to take a value 3.14, it doesn't matter where A is. A can be first variable, second variable, third variable, hardly matters. But what matters in keyword arguments is do not try to change the name of the variable, because that's going to be disastrous. Names will have to be matched. That's the need for keyword arguments in a function call. Sometimes we may combine positional and keyword arguments. If we do so, realize that positional arguments must be at the beginning and then only keyword arguments can begin. Suppose we have the same print it function and then I start making calls to it. 10, A equal to 3.14, str equal to ngp. 10 will go into I, A and str will have values 3.14 and ngp. So this call is perfectly acceptable. If I say 10 str equal to Nagpur A equal to 3.14 means I have exchanged these. This has gone here, this has gone here. And 10 is the positional argument in both calls. Positional arguments are occurring before the keyword arguments. So this call should be equally okay. This is fine. Third call, however, is problematic because 10 has come after the keyword argument. 10 is a positional argument. It should have been at the beginning. So the moment I put it in the middle, that's an error. This is also wrong because 10 has gone at the end. Positional arguments we said should come before the keyword arguments, whereas in these two cases what has happened is positional arguments have been out of place. They have come after the keyword arguments. That's unacceptable. So that explains how to communicate between functions and how to make use of positional and keyword arguments either separately or together. What we haven't covered is variable number of positional arguments and variable number of keyword arguments. And that is what we plan to do in videos to follow. Till that time, goodbye, good luck, and thank you.